Thank you for coming to my talk. My name is Ariel Wolfmann, and I will talk about recommendations at Rappi. So, first of all, about me, well, I started as a data scientist some like 5 years ago, stuff like that. And now I'm leading a data team around 25 people in Argentina. I'm from Argentina. And I'm also one of the organizers of PyData Córdoba, that is the PyData in Argentina. And regarding to the day-to-day work, I like to bridge the gap between like product and business people and technical people, because most of the time there is a big gap there, like completely two different languages almost. About Rappi, I don't know if you have heard about, but Rappi is like a super app, mostly focused on last mile delivery, online groceries, restaurants, and fintech. Rappi is the first Colombian unicorn, and actually works in most of Latin America. So just a disclaimer, I know what about your what you're expecting about the technical part, but it will be mostly focused on how to put your machine learning models into production and how to bridge the gap between the product and the technical part. So the first question I have is, what's the value of business value of a machine learning model? And well, from my point of view, the machine learning model by itself, the value of that is zero, because the value is on the product that you have built on top of it. For example, in a recommendation system, the machine learning model is just a little part of the product, but you have a complete product on top of it, building, let's say, different use cases. For example, if you want to show similar products, complementary products, or personalized recommendations, stuff like that. So the value by itself is on the product, not only on the machine learning model. So regarding to that, I would like to introduce the concept of the data product. On the product management side, we have a technological product that the difference with a data product, the data-intensive product, is the goal of the product by itself could be not achieved if we don't have the data. We rely on the data to achieve the goal of the product. Another interesting point is you cannot just buy good data products. I mean, for example, I would like to buy a recommendation system, but I mean you can buy, but you will mostly rely on the data you have to provide it. So, well, there is another, I don't know if you have heard, but there is a lot of phrases like data is the new oil. So at some points, they have similarities, both of them needs to be transformed into a product, for example, before it's valuable. But the difference with data and oil is once you use the oil, it's gone, but the data is persistent, so you can still using it over and over. Well, so continue talking about the data product. There is a challenge. Almost every product have the challenge to fit to the market. That's the main challenge of every product. I'm giving to the market what the market is requiring. But also on a data product, you also need you have another source of uncertainty that is the data. Because previously, to start working on your product, you don't know exactly how good is the data to predict, for example, or to help you to achieve your goal. Mainly because predictions are not always correct. You don't know exactly, you cannot guarantee the performance of the model like in advance. And it could happen that you don't have enough data or enough signal to make a good prediction. And also, even if the model is working OK on the training set, but after you put it on production, like to deploy it, the performance could vary like significantly. So I love this graph, this plot. Like, there is a misconception on what will be like the effort allocation on a data product, on a data project. And the expectation mostly will be like, OK, I will be working on optimizing my machine learning model, my machine learning algorithm most of the time. I just will sometime working on defining the KPIs, the key performance indicators, stuff like that. But on the reality, on real world cases, and at least on my experience, that's not the complex part. You will have like many others part of the project that will require you a lot of effort and time. For example, collecting the data, or building the infrastructure, and even the integration process. All of that will take most of the time, and optimizing the machine learning algorithm will be just a little part of that. So even for the new data scientists, like they are expecting, oh, I will be working on modeling and doing some machine learning cool stuff every day and most of the day. But that's not true. I'm sad to say that. Because there is a big problem, like how to integrate, how to build infrastructure, how to collect the data for the problem that you are tackling. So another concept I would like to mention is well, we have big data. I used to hear oh, we have a lot of data, what we could do with that. And on real cases, on real world scenarios, the problem is not the size of your data. It's how you use it and how much information you could take from it. Regarding to that, I will not go in so deep on this, but there is some concepts regarding to the data quality. You need some completeness, some validity, some accuracy, integrity, consistency. There are a lot of validations that you need to check on your data previously to start working maybe on that. Because if not, almost of your work will be will have an error, or probably when you are going to production, will fail. So as I said, I used to work as a consultancy also, and I used to hear we need to do something with our data. What we could do this? And that's not a data science problem. It's mostly a data strategy that probably the company should define. And the idea of this is OK, let's find some valuable question that data can answer you, and after that, we define what is the return of the investment on working on a data science project regarding to tackle that problem. It could happen that your data, your problem could be solved, but a completely and simple software development tool or some rules or stuff like that. And you need to start working on a machine learning and complex algorithm. So to still talking about like some part of the product management side, there is a concept like it's the minimum valuable product. I know an MVP. I don't know how many of you have here. Please raise your hand. Well, most of you. So, well, basically the idea of this is that if you're trying to build a car, you will not starting like building one wheel, then the second wheel, then the base, and then the complete car. Instead of that, you will try to, okay, let's build a skateboard firstly. Let's validate that the user needs a skateboard, and probably it could happen that it not solve the complete problem, but you validate that your way is like the correct way. After that, you can start working on a scooter, on a bicycle, and then a bike, and after finish that, a car. So like iterating on that, you will learn a lot, and adapt the time to adapt to the customer will be much faster. And well, probably for an MVP, you will not need any conception of AI or machine learning or stuff like that to feel the product smart. Maybe we will just some rules, that's enough. So 2 questions I love to have on starting like an MVP is, what is my riskiest assumption I'm taking on for take the product? And what is the smallest experiment I can do to test that assumption? So having that in mind will help you a lot, like working in the same scenario like on the skateboard, the scooter, stuff like that. You will be validating that, and you will not lose a lot of work once you go to customer and say, oh, no, I don't need it. That's not important for me. Another concept for this is like time is critical. So I hardly recommend to always start simple and establish a baseline. And after you have a baseline, you will start working on all of the part that I mentioned before, like integrating, building the infrastructure, that data collection, or of that other part that will help you a lot to get it on production early. Maybe just, okay, let's build, for example, an API that always returns the same value. And see with that how to integrate with the rest of the architecture of the project or stuff like that. And by the other side, there are a lot of research tasks regarding to a data science project. And what I recommend to do is like time boxing them. I don't know, if you need to research on some specific area, okay, you will have 1 day or 1 week or whatever, but on that time box, you will need to have an answer. It could happen that it's not the optimal answer, but it will help you to continue iterating. If not, it could happen like, okay, I'm spending 2 months researching what is the optimal solution for this, but probably with a simpler solution, I can start iterating over and over then. And in the same line, like experimentation, as I mentioned before, you need to experiment a lot and test a lot of hypotheses. Like the first part will be like defining your goals. What is like the product goal? And it's kind of related to the product discovery phase on the product management side. And once you have that, you can start turning your ideas to hypotheses to validate. Once you define your hypothesis, you can start working on designing your experiments that will let you validate or not your hypothesis. With that like framework, you will have like prove your theory or intuition with science. And even if you need to validate on production, you could do some kind of A/B testing or stuff like that to validate, but with just a part of your customer, of your data, whatever. But like as the meme before, like start simple and small, and then iterating on that. Another concept is like it's really important to have the metrics. Like the analytics infrastructure, at least on e-commerce or any web page almost, it's a must for applying any data science. And after that, you have like two kind of metrics. Like you have like online metrics and offline metrics. Mostly the online metrics are related to the key performance indicator or business metrics like outcomes, conversion, stuff like that. And you also have the offline metrics that is more like related to the modeling metrics, like accuracy, precision, recall, what were like mentioned before on the other talks. And one of the biggest challenges on a data product is like having correlation on the business metrics and the offline metrics, like on the modeling metrics. Since, okay, most of the business people will ask you, okay, if you improve 5% your accuracy of your model, how much will improve the conversion, for example? And that's the hardest part. So I recommend you to work like hardly defining that correlation, and once you have that, you can still go in and over. Just an example, I don't know if we have people from Netflix here, but an example of recommendations. Let's say, for example, a series like Stranger Things. For the same series, Netflix show you different like pictures or images depending on your customer behavior or what you were like seeing or watching before. And they also like used to sort them by some criteria, different series or stuff like that. I don't know if you heard about, but it's like a famous Netflix prize that was like 1 million prize for a championship regarding to a recommender system. Netflix, like the idea is predict accurately like movie customers would like. And well, there was like a competition. There was a winner, and after that, the winner solution will never came to production due to the engineering cost of that. So, what's the message I would like to give you with that? Is like doing a completely complex model could be like the state of art in the research area, but going to the production or into the day-to-day work, it may not happen the same because there are a lot of different factors that could be involved. Another point is like human in the loop or human behind the machine learning. Well, there is a picture in Spanish, but basically Netflix was paying people for tagging some series. Okay, this is a comedy series, this is a horror, or this is a thriller, whatever. And why we used to have like humans behind or in the loop for the machine learning? Because it helped us to learn much faster and much more accurate than giving completely the control for the machine. And also help us to teach the machine with some good base of data. So you don't be scared of like tagging or stuff like that. Is like part of the work like day-to-day work on almost every data scientist. Well, and continue talking about recommendations. There are like some concepts that you should like, or requirements that you should like achieve on your recommendations. There is a concept of relevance, that the items you show should be relevant for the user. You should also have like some concept of diversity, like if you show always the similar items, the chances to convert are lower than if you show completely different items. There is another like item fatigue, like if you show always the same items to the user will stop looking on your recommendations, and after that you lose the fidelity of your customer. Well, you also have like the novelty of freshness. Like there is a time dependency. What happens if you show as a recommendation, let's say on Netflix, if you recommend a movie that the customer already watched? So it could happen that watch it again, but most of the time you will not convert with that. And also there is another concept that is serendipity. Like it's related mostly to surprising the customer and like be attractive for them. And with that requirements, you also can have completely different goals, depending on what kind of recommendation you would like to show to the user, to the customer. The goal could be completely different. You would like to increase your average ticket size or value. You would like to increase your buy frequency, or even you can have the objective to stock clearance, like, okay, I have these long tail products and most of the people are not seeing them. How you could like showing more. And also could happen like to promote some brands or product that you have like some okay, if you get it this, maybe the commission I higher or stuff like that. And also it depends if you want to increase your customer loyalty. If the customer feels like you as a site system or as a site knows him a lot, like the loyalty will increase. And well, basically, like going just a little bit deeper on the technical part, the recommendations are basically a learn to rank problem. So there are some metrics, like modeling metrics, regarding to learn to rank. You have precision at key, recall at key. F is like a mix of precision and recall. MDCG is like you will, since it's like almost sorting a list, it's a problem of sorting a list. What if you show the top one on the second position, and what if you show it on the third and stuff like that? Like it's like giving that idea. And also you can have the idea of coverage of your complete catalog. How much of your items are you showing like as a recommender? And still going on that technical part, just mentioning what we built on Rappi. Since we have a ton of data from the analytics part, and also from transaction and different sources, we try to train some embeddings, like it's like a vector representation of each product or each item we have. And based on that, depending on what is the goal of the recommendation we would like to show, we train with different sources. For example, if we would like to recommend similar items, we train the embeddings with the content of each for example, the script, the title, description, nutritional facts, stuff like that. And if you would like to recommend complementary items, probably what we have to as a source of data for that is like mostly related to the context. Since we have a cart of, let's say, 5, 10, 20 products on the cart, we saw like or most of the time the customer used to buy jam, also used to buy cheese and bread. So with that notion of context, we train that, and using that we can like use almost any like tool, famous tool like Word2Vec, Fasttext, BERT, or even combine multiple of them to make some embeddings. And also you can build like a user embedding based on the customer behavior, and from that, like it's just like measuring the distances between the products embeddings and the user behavior embeddings. That is like, well, it's mentioned here. What about personalization? Well, what we did on regarding to personalization is like build an user embedding based on the customer behavior. But since we were working on that, we have get in front of the cold start problem, that what happened with the customer that we don't have enough data to build an embedding. So what we do on that is, for example, clustering that was mentioning on the previous talk. Like, okay, this user seems to be similar to all of that. Like collaborative filtering is also a known technique to tackle that. But you also need to like have real-time predictions. You get in front of bigger computational costs, and you will need to work harder on the feature engineering. You will need like a user feature store to have like on real time, okay, show me what is the device of the customer, which is the city, most of the information that you may have offline, like from previous information, but also you will need to, okay, what's the last item the customer bought. So depending on the goal you are tackling, you're looking to achieve, like you could get or have like diminishing returns, since it doesn't make sense to get personalization on completely everything on your recommendations. Like if you need to measure that, okay, if we increase the accuracy of the model for each user, how much money we will get it from it. Just a mention, we use Airflow as like for the data collection, as I mentioned before, for ETLs, and also to retrain our models. Like we use this. This is an open source project, and works really good with that. Well, and another example on recommendations, Amazon. I don't know also if we have people from that. But what I would like to mention from here is like, well, Amazon report like 35 of its revenue was generated by recommendations engines. Well, okay, but that's not a pure science. You require also some UX or like explainability on your recommendations. As I mentioned before, it's a complete product. So if the science works really good, but the user experience is really bad, you will not convert this as it. Also, an example I took from another PyData I've been before is like how the UX matters on the recommendations. For example, here on booking, if you show like, okay, 88% of the available hotels on the city you are looking for are are done, that like creates a sense of urgency to the customer, and that will be a better driver than even if you show the best recommendation for that. So again, mixing data and UX is like the way to go, not only UX and not only data. Just an example about how we worked at Rappi on recommendations. Well, we started with some like different approaches. Like, okay, let's start with random items and let's see how they convert. Then we show like, okay, let's show top solds or show trending items. And with that, we start validating the infrastructure, the analytics, the metrics. We did an A/B testing for that, and for that we have a baseline. After we have all of it done and ready on production, we start working on the like a Q-occurrency model that is mostly statistical. So with that, we have like an informed baseline that I don't know if you heard about the Pareto law, that is like 80-20, like 80% of your problem will be tackled on 20% of your time, and the rest 20% of your problem will need like the rest 80% of your time. So with that, probably it's enough, and you don't need to get on the machine learning stuff. But if you need the machine learning, let's start with simple models like linear regression, or also defining some hypotheses and experiments. And after that, start working on complex models like offline predictions. After that, getting on the deep learning or neural networks. And once you have all of this, let's start thinking about personalization. And like working on parallel with the user experience, like defining the UX flow, the UI views, interactions, stuff like that, and still improving that, like the user experience, will help you almost the same as improving the model. So just an example, like not going complex on the model, going like better on what are you showing as a recommender system. And I think we are. I don't know if you have any question.
Thank you for the talk. I do have a couple of questions. The first one, when you're building the models, are they user agnostic in essence that do you have a priori information about the user, not the process purchases, but the actual user, like personal information when they sign up or something, or you're building a user agnostic model?
No, as I mentioned, even with the personalization part, we don't know personal information of the user. At mostly, we could have information about what type of device it have or the city, like demographics, but not personal information.
But you'll have past purchases or past interactions.
Yeah.
So the user is anonymized, but you...
Exactly.
Okay. And the other question is also the personalization. So how do you capture the signal for offline testing? Do you have implicit feedbacks or explicit feedbacks, or how do you get that they like this specific product?
We have implicit feedback. So, I mean, the user could give feedback to us. Oh, I like this product a lot, but mostly of the user don't give us. So what we do is working on what the customer behavior was, like what he bought before, previous orders, stuff like that. And yeah, basically that. I don't know if I answered your question.
Yeah, thank you.
Cool.
So I'm just getting into talk. Apologies if you said this plainly in the beginning, but I'm kind of took a brief look at some personalization of the service.
Don't look here. I know.
apologies if you talked about this earlier on in the talk. I missed the beginning. But do you have any views on, so I know AWS personalized and Google has an equivalent offering where they offer personalized recommendations of service, and it comes along with some of these built-in features like implicit and explicit profiles, meaning like here's a profile for a specific user versus like here's somebody from Austin, Texas who's, is in this demographic bucket. Do you have a sense of like what are some of these like personalization as a service options that are available out there and how they compare to things that people have done in-house? Not necessarily just at in your company, but just across the board.
Well, as I mentioned, like in the some of the first slides, let me find. As a data product, from my point of view, or at least on my experience, I think that maybe Google or big companies are working hard on getting better data products, but most of the time you cannot just buy a data product as a personalization system. Mostly related because you are hardly rely on your data, and because of that, I mean you can share your data with Google and Google work on that and then giving like information to you. But from my point of view, is at least right now there are like I prefer to build in-house that part of the work.
What's your cycle in terms of pushing the MVP and checking whether if it's effective and what's the reaction? How long does that take for you?
Well, that's a really good question. It really depends on the kind of product you are going, but let's say like between 1 month and 3 months, having information and knowing, okay, we are having some errors with dice, or like iterating and almost every time learning information about what you have right now in production. Because of that, you will improve the next iteration, let's say.
And how often do you find yourself after 3 months that this doesn't work, I have to throw the whole thing away?
Well, the other like we used to have like is the A/B testing. So we are showing like different parts of the customer, different models. So if a model is its performance is better, we will give like more part of the customer showing that model instead of the other one, and also learning why one is better than the other.
Any more questions? Okay, thank you, Ariel.
Thank you.